We present DQNViz, a visual analytics system to help deep learning experts to understand, diagnose, and potentially improve deep Q networks. DQNViz consists of the following four components: a statistics view presenting the overall statistics of a DQN training with small multiples of line charts and stacked area charts, an epoch view demonstrating the action and reward distribution in the selected epoch with the combination of a pie chart and a stacked bar chart, a trajectory view revealing the movement pattern and reward pattern of the DQN agent in individual game episodes with the support of an on-demand training details, and a segment view, using the guided backpropagation algorithm to reveal what the agent really sees from the selected segment and enable the comparison of different segments. We now demonstrate how DQNViz works by analyzing the data collected from the breakout game. We target to demonstrate how the four views of DQNViz can present the DQN training process in four levels of detail. From the statistics view, we can see the collected data present a successful DQN training as the average reward per game episode is increasing and the number of games per epoch is decreasing. This means the agent can destroy more bricks in each game episode with less life losses. The estimated Q value is also increasing, indicating the network expects to achieve higher and higher rewards over the training. From our statistics collected for different patterns, we also found that the number of bouncing patterns keeps increasing over the training. More summary statistics can also be plugged into this view and presented as juxtaposed line charts. From the stacked area charts for the reward distribution, we can see that the 4-point and 7-point rewards take an increasing portion of the total rewards. The action distribution, however, does not show any obvious temporal trend, even in the later training stages. This observation indicates that the agent can achieve high rewards with different movement patterns. In the first training epoch, the performance of the agent is very poor, as indicated by the average reward and the number of games. From the epoch view, the agent takes a lot of moving left actions, and the achieved rewards are mostly 1-point rewards. By synchronizing the epoch data to the trajectory view, we found the movement patterns of the agent are mostly the same in individual episodes, and the agent always stays at the left side of the scene. With the training moving forward, we can see the agent becomes more and more flexible in moving the paddle, as indicated by the results in the trajectory view. The reward distribution of epoch 37 does not follow the general trend. By hovering over this epoch, we can see a spike in the line chart for the number of games, indicating there are a lot of life losses in this epoch. From the epoch view, we know that the agent moves the paddle left and right for most of the time in this epoch, and it mostly hits bricks at the bottom two rows, as most of the episodes receive only 1-point rewards. By synchronizing the data of this epoch to the trajectory view, we found a lot of hesitating patterns, which lead to the poor performance of this epoch. Clicking the action sequence to investigate the details, we can see that the agent does not know that he needs to fire the ball at the beginning of the game, and he mostly switches between the moving left and moving right actions on the right side of the scene. We also found some epochs that have very uneven distribution of the actions but achieve good performance. For example, in epoch 190, 79% of the actions are no operation, but the reward distribution looks very good. By checking the agent's movement details in the trajectory view, we found that the agent gets very smart in this epoch and performs a minimum amount of moves. For example, in this digging pattern, the agent finds the best position for him, which can catch the ball from both sides of the scene with only a few moves. Now let's focus on epoch 120 to explain our result reported in the paper. This is a normal epoch, as all statistics follow the general trend. The agent takes a little bit more moving left actions than the other three, and the count of 7-point rewards is a little bit more than the other two. From the hierarchical clustering result, we can quickly explore the 25,000 steps in this epoch. For example, the currently selected branch highlights segments that frequently move paddles between the lift boundary and the middle point of the scene. By synchronizing the reward data, we found this type of segment often appear right before the bouncing pattern. By checking the details in the screen data through the video clips, we confirmed that these patterns are actually the digging pattern, and mostly the agent is digging the right corner of the bricks. By zooming into different hesitating patterns and highlighting the random actions, we know that the random actions play an important role in terminating the hesitating patterns. Also, in some cases, a single random action is not enough to completely terminate the hesitating pattern. In the trajectory view, we can also select interesting movement segments into the segment view for comparison. Here we select one short segment in which the agent moves the paddle from one side to the other, and a long segment which encodes the digging pattern. The two segments are presented as two rows of bar charts in the segment view. Each bar represents a convolutional filter, and the height of the bar encodes how strong the segment activates the filter. We can switch between different rows to see their similarity in the PCA view. From there, we can also perform lasso selections to highlight what has been activated by different groups of filters in the average state. From the user interface, one can choose to focus only on one layer of filters and sort the filter bars based on their height. The short segment captures the moving path of the ball and paddle, and the filters from layer 1, 2, and 3 follow an inner to outer layer on the PCA view, indicating the higher layer captures more diverse features. We have also tracked the short segment in two early epochs and compare them with what we have seen in epoch 120. From this comparison, we can see that, in the early stages, the agent does not have a clear vision on the movement of the ball and the paddle. We have also explored DQNViz with the Pong game. Details about the explorations can be found in our supplementary material. Thank you for watching.